Hello, grade 9. How are you, miss? Lesson 1 from module 3 is about graphing quadratic functions. Now, at the end of this lesson, you will be able to identify the axis of symmetry, the vertex, the domain, and the range, and intersection, for a given parabola with the y-axis, with the x-axis. All of these are actually characteristics for the quadratic functions graph. And, finally, we will learn how to graph quadratic function. Now, as you can see here, first, the standard form of the quadratic function is y equals ax squared plus bx plus c, where ax squared is the leading term is actually the quadratic, term, bx is the linear term, and c is the intersection of this function, of the quadratic function, with the y-axis. Now, for example, what's the linear term of y equals 4x squared minus 3? As you can see here, since there is no x, which is actually the linear term, we can say that there is no linear term. The linear term here is 0. Now, going to the quadratic functions graph or graphs, the graph of a quadratic function is called parabola. And it actually has, same shape, but some two shapes, one of them looking upward and, the other one looking down. Now, or it's open up or open down. If it's open up, the lowest point is called the vertex, and we can see here that the vertex has it's the minimum value of all of the points on the graph. And if it's looking downward, the vertex is the maximum value of all of the points on the parabola graph. Now, for example, the standard for sure for the quadratic function is ax squared plus bx plus c. Now, if a is positive, we can see that the graph is looking upward. If a is negative, the graph is looking down, and we said that the vertex has a maximum value, while if a is positive, the vertex has a minimum value. A mustn't be equal to 0, because if a is equal to 0, we don't have actually a quadratic term, so it will be a linear function, not a quadratic function. So make sure that a mustn't be equal to 0. Now, there is one of the characteristics for the parabola is the axis of symmetry. Axis of symmetry, it's a line that divides the parabola into two identical shapes exactly. If you look at it, you can see that the right side is exactly a reflection of the left side, or the left side is a reflection of the right side. For here, if you know where is the axis of symmetry line, which is here, we can imagine or conclude immediately that the other side of the parabola will be to the left, as you can see here, because the axis of symmetry, it divides it into two identical shapes. Now, how to find the axis of symmetry? Since it's a line, vertical line, it's not a function. It's a, it's a vertical line. So we don't say y equals for its equation. No, equation for axis of symmetry is x equals value. Now, what's the value? It's negative b over 2a. This is formula. You have to memorize it. And notice that negative is a basic. It's original in the formula or in the equation. So, if you want to find the axis of symmetry equation, all you have to do first to write the values of a and b, this is better for you, and it makes your solution much easier. A here is equal to 3, and b here is equal to negative 18 and not positive 18. Now, then what you will do, you will divide 18 by 2 times 3, because actually negative, it will give you positive, and 18 over 6 is equal to 3. So the axis of symmetry equation is 3. Since the axis of symmetry is passing through the vertex, as you can see here, so the axis of symmetry gives us the x coordinate for the vertex. How can I find the y coordinate? By replacing x coordinates in the equation of the function. Now here, for example, if you have been asked to find the axis of symmetry equation, all you have to do is use the formula and then replace values of a and b, and then find x is equal to 2. Now x is equal to 2 is the equation for the line, for the vertical line, and it's also x coordinate for the vertex. Now to find y coordinate for the vertex, all you have to do is replace x by its value by 2. So when you replace it by 2, as you can see here, then find the value. Y will be equals to 5. What's y? This is y coordinate for the vertex. So the vertex here, as you can see here, is 2, 5. The vertex, it's a point. And from sine of A, which is, as you can see here, is negative. So from sine of A here, we can notice that the, this parabola is looking downward, and this vertex has a maximum value. It's the highest point in the whole parabola. These are the steps finding or graphing. It's very important to find the other 2 points and reflection for them across the x-axis, axis of symmetry. Now, 3 points for graphing parabola is enough. One of them will be the vertex. The other one will be the intersection with the parabola with the y-axis, which is C, the last term. And the other or the last point will be the reflection of the intersection of the point on the y-axis or with the y-axis, reflection for it using the axis of symmetry. Now, for example, here, find the axis of symmetry using the formula. It will be equal to 1. Now, I want to find y, so I have to replace x by 1. So the value will be -3. So this is the point. The point will be at 1, -3. This is the vertex. And according to the sign of 2, which is a, and which is actually a positive, so it has minimum value. So the parabola is looking up, okay? And as you can see here, we can choose point, or we can just say that the intersection of this parabola with the y-axis is -1, and this is enough. Sorry, this is -1. This is y-axis, and this is the vertex. We can see the reflection across y-axis on the other side. The distance between, intersection of the parabola with the y-axis, the distance, which is 1 unit, will be exactly here for the reflection point. So I have here 2 points, and you can see I can just watching how the 2 points can be graphed. Yes, we can choose these 2 points, any point in the positive side, and find the reflection on the negative side. Now this is how we graph it. So to graph parabola, all we need is, finding axis of symmetry equation. Use it as x coordinate of the vertex, find y coordinate, then find the vertex point, decide if it's looking up or down according to the sign of A. There is intersection of the parabola with the y-axis. If there is no c, no constant, so intersection will be 0. So the graph will be passing through, through the 0 point, the original point. And then find a reflection of this point of the, y intersection point reflection on the other side according to the axis of symmetry. This is all we need to graph quadratic function.